What is up, math superstars? This is Mr. Peterson bringing to you Objective 6.17, Arithmetic and Geometric Sequences. First, we're going to talk about what arithmetic sequences are and provide some examples. And so with this, we're going to be given a series of numbers, and with arithmetic sequences, we're going to figure out what the common difference between the numbers are. And all this means is, what number did we add or subtract in the sequence to get the next number? So here we go. Let's try example number 1. So here's a question. What are the next 3 terms in the sequence? And so the arithmetic sequence means we're either going to add or subtract by a number. And so how do we go from 3 to 5? What we did was we added 2. So to go from 5 to 7, we added 2. 7 to 9, we added 2. And so to get our next number, we're going to do 9 plus 2 is going to give us 11. So to find the next number, we just add 2. 11 plus 2 gives us 13. And to find the third term in the sequence, we're going to add 2, and it's going to give us 15. So now let's go to example number 2. And so what are the next 3 terms in the sequence? So to go from 34 to 31, we subtracted 3. To go from 31 to 28, we're going to subtract 3. To go from 28 to 25, we're going to subtract 3. So now to go from 25 to our next number, we do 25 minus 3 is going to give us 22. And then we have to do 22 minus 3 is going to give us 19. And then 19 minus 3 is going to give us 16. So now it's your turn. Go ahead and pause the video where it's at right now and see if you can solve for the next 3 terms in the sequence. Okay, let's see if you got the correct answer. So 19 to go to 29, we're going to add 10. 29 to 39, we're going to add 10. 39 to 49, we're going to add 10. So 49 plus 10 is going to give us 59. 59 plus 10 is going to give us 69. 69 plus 10 is going to give us 79. So now here's a second one you can try on your own. Go ahead and pause the video where it's at, and we're going to pick up here with the answer in a few seconds. So what are the next 3 terms in the sequence? And so to go from 64 to 55, we subtracted 9. 55 minus 9 gives us 46. 46 minus 9 gives us 37. So 37 minus 9 is going to give us 28, and then 28 minus 9 is going to give us 19, and then 19 minus 9 is going to give us 10. So now we're going to talk about geometric sequences. And so this is all about, the question is, what is the common ratio between numbers? And so with that, we're either going to multiply or divide in our sequence. So for our first example for geometric sequences, we need to find what the next 3 terms in the sequence are. And so with geometric, we're going to multiply or divide by a number. And so here, to go from 2 to 6, we multiplied by 3. 6 times 3 gives us 18. 18 times 3 gives us 54. So now we have to do 54 times 3, and it gives us 162. Then 162 times 3 gives us 486. And 486 times 3 gives us 1,458. So with geometric sequences, all we're doing is we're multiplying or dividing by a number. So now we're looking at example 2. And so to go from 81 to 27, in our sequence, we're going to divide by 3. So then to go from 27 to 9, we divide it by 3. To go from 9 to 3, we divide it by 3. So now we're going to do 3 divided by 3 is going to give us 1. And then 1 divided by 3 gives us 1/3. And then 1/3 divided by 3 gives us 1/9. And so here in a geometric sequence, just like our first example was multiplication, now we're just dividing by the same number to find the next number in the sequence. So now it's your turn. What are the next 3 terms in this sequence? Go ahead and pause the video, come up with your answer, and then you can check your answer here on our screen. So now let's go ahead and go through this answer. So to go from 2 to 8, we multiply by 4. So 4 times 8 gives us 32, so we multiply by 4. 32 times 4 gives us 128. 128 times 4 gives us 512. 512 times 4 gives us 2,048. 2,048 times 4 gives us 8,192. So once again, it is your turn for the geometric sequence. So what are the next 3 terms in the sequence? So go ahead and pause the video where you're at, come up with an answer, and we'll walk through it together. So to go from 1,331 to 121, we went ahead and divided by 11. So 121 divided by 11 gives us 11. So then 11 divided by 11 is 1. So 1 divided by 11 gives us 1/11. And then 1/11 divided by 11 gives us 1/121. And so you can see when we go ahead and do this division, so you kind of see the pattern here. See our denominators? Our denominators match up with the other side. So if we went ahead and continued this sequence, the next number in our sequence, if we divide it by 11, would be 1/1331. So we can kind of see how this matches up without even using a calculator. Next, we're just going to mention some specific types of patterns here. So we have the perfect square pattern going on here, and so we can see our perfect square number is 4, and so this is a 2 by 2 array, so we can see that listed here. So to go to our next perfect square number is a 3 by 3 array, and so if we use the 4 by 4 array, gives us a perfect square number of 16. And so if we did a 5 by 5 array, gives us 25. And then a 6 by 6 array gives us 36. And so this is just one type of pattern that we have here. These are just the exponents. So if we did 2 squared, 3 squared, 4 squared, 5 squared, and 6 squared, it's going to give us this pattern. And we can keep going on with this pattern. 7 squared will give us 49, which is a perfect square, and so on and so forth. So now we're going to talk about triangular patterns here. And so we're going to be given some different patterns. So we're going to start off in our pattern. So we have 1 in our pattern. So then if we add a second row, so we went from 1 plus 2 gives us 3. So next in our pattern, if we added 3, it's going to give us 6. And then if we add 4, it's going to give us 10. And then if we add 5, it'll give us 15. And so this is called a triangular pattern, because what we're going to do is we want 1 plus 2 gives us 3, plus 3 gives us 6, 6 plus 4 gives us 10, 10 plus 5 gives us 15. And so all we're going now is in order. And we keep going on with this pattern too. If we did plus 6, so we do 15 plus 6 gives us 21. And then 21 plus 7 will give us 28. And then we just keep going on and on with this sequence. This is called a triangular pattern. The next sequence we're going to look at is called the Fibonacci sequence. So what this does is we take our first two numbers and we add them together to get the next number. So 1 plus 1 gives us 2. And then we take these two numbers, 1 plus 2 gives us 3. And then we group the next two numbers. 2 plus 3 gives us 5. And we take the next two numbers. 3 plus 5 gives us 8. Then we group the next numbers. 5 plus 8 gives us 13. And we group the next two numbers. 8 plus 13 gives us 21. And then when we group the next two numbers, 13 plus 12 is going to give us 34. And we keep going on and on with this sequence. So in the Fibonacci sequence, this is really neat because when you go on Google, you find some really cool images here. And so in nature, the Fibonacci sequence can be seen all over the place. And so you see it in patterns in flowers and in different types of shells and things. But I really encourage you to explore. Look up the Fibonacci sequence. It's right here. So you can't go wrong with this. So make sure you spell it properly. Google will help you spell it, so don't worry. But you can check out some really neat ways that math is embedded into nature. It's super cool.